Alright, we're going to keep going with our Unit 2 study guide on polynomials. If you are following the other problems, you'll notice we are now on problem 3 for the second time. That's right, there are 2 problem 3s on this sheet. Who knows why, but that's okay, we're going to do it anyway. So, problem 3a says completely factor the rational expression, state the values of x where there are wholes, vertical asymptotes, and zeros of the given equations. So basically all we got to do is factor the numerator and factor the denominator. So let's go ahead and look at the numerator. 2x cubed plus x squared minus 2x minus 1. Generally speaking, when you see 4 terms and you're trying to factor it, it's a good idea to try and factor by grouping, which some of you referred to as the squiggle method. I'm not sure who taught you that, but okay, cool. Squiggle method it is. So let's look at it. Let's rewrite it as 2 different groups. 2x cubed plus x squared plus negative 2x minus 1. And now you're just seeing what you can factor out of each of these terms. And it should work out nicely. So the first one, let's just factor out x squared, because that is the greatest common factor of these 2 terms. So we factor x squared out. What are we left with? Well, you ask yourself, what do you need to multiply x squared by to get to 2x cubed? Well, you need to multiply it by 2x. What do you need to multiply x squared by to get to x squared? Well, you need to multiply it by 1. Cool? Let's look at our second term here. What can we factor out of negative 2x minus 1? Well, let's just factor out a negative 1. That's kind of hard to see. Let's factor out a negative 1 because that's our GCF there. Clearly, because that last term is negative 1. You can't really factor anything else out of it. So what are we left with? Well, we're left with negative 2. I'm lying to you. We're left with 2x plus 1. Which, honestly, we should kind of be thinking we're going to get that too, because our goal of factoring by grouping is to get the same term there and there. So cool, we got it. All right, now let's go ahead and rewrite this as x squared plus 1. So I'm taking that term and that term. Essentially what I'm doing is I'm factoring out, sorry, I'm dealing with the pen. Basically what I'm doing is I'm factoring 2x plus 1 out of each of these terms, which seems weird, but it's awesome. So let's factor it out. And what are we left with? Well, we're left with 2x plus 1 times x squared plus 1. And if you think about it, we could redistribute this 2x plus 1, the whole thing, and get 2x plus 1 times x squared, which is what we have right there. And we can get 2x plus 1 times 1, which is what we have here, but I'm realizing I made a mistake because that's actually supposed to be a negative 1, so let's fix that. So 2x squared minus 1. Okay, cool. Glad I caught that mistake. That would have been unfortunate. Okay, well, let's go ahead and factor that term right there, x squared minus 1. Again, if you recognize that's a difference of squares, cool. Let's do it. Let's write it as x minus 1, x plus 1. And then we have 2x plus 1. So the question says, if we go back to it, we actually have all of that. That was our numerator over our denominator, which we were given as 2x plus 1 times x squared minus 6x plus 9. Okay, that first term in the denominator is already as factored as it can be, but we can factor that term, certainly. So let's do that. I'm just going to rewrite the denominator as we already have it. X minus 1, x plus 1, 2x plus 1, all over 2x plus 1 times, now we're going to factor that, which we can factor as x minus 3, x minus 3. Negative 3 times negative 3 gives me positive 9, and negative 3 minus 3 gives me negative 6. So I'm good. Now we just need to do a little looking at what we have here to figure out where we have our holes, asymptotes, and zeros. I look at holes first, because if there's a hole in our graph, we don't want to mistake it for a asymptote or a zero. So that's a good place to start. So to identify your holes, all you got to do is look and see where you have the same term in the numerator and the denominator. So if we look at that part, 2x plus 1 in the numerator and the denominator, that is going to be a hole. So all you got to do is find out what that x value is that makes it 0. 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. Okay, so we have a hole at x equals negative 1/2. Alrighty, cool. Next step, let's find the zeros. So if you think about when a fraction is going to be equal to 0, we need our numerator equal to 0. So we've got these two terms there. Well, those are linear factors, so that's super easy. So we have zeros at x equals 1 and x equals negative 1. Alright, almost done. Last thing we need to do is see when this function is going to have a vertical asymptote. So for that, vertical asymptotes happen when we are dividing by 0, which you can't do. So we look at when our denominator is 0. I'm mixing them up for some reason. But we can see that we're going to have a vertical asymptote at, I'm just going to write that VA, at x equals 3. And we should look at that term, but it's the same, which of course we could write as x minus 3 squared. And we see that we have a hole at x equals negative 1/2, a 0 at x equals 1 and x equals negative 1, and a vertical asymptote at x equals 3, and we are done. It says completely factor, so probably I would write it as, there's no way I'm going to have room to do that there. I would write it as x minus 1, x plus 1, and I'm forgetting it, 2x plus 1 over 2x plus 1, and then this last step I'm just going to combine those two linear factors to get x minus 3 squared. And we are done. Hooray!